Okay, so in the second one of these experiments, what we have to do is we have to measure how the speed of the wave changes with the depth of water. Now, if you might remember that the first time we did this, we found if I put it right over there, it was a bit deep. If I put it right over there, it was a bit deep. If I put it in the middle, it was a bit shallow. So I'm going to go for there. Now, it's still not very easy to read, but I reckon that's 5 mil. So my first depth is 5 mil. And what I'm going to do, because I know now that it doesn't change speed, I'm going to do it for 5 crossings. Now, in my preliminary experiment, I found that at 5 mil I couldn't actually see 5 crossings. I'll just show you. See if you can see 5 crossings. 1, 2, 3, and then possibly 4. So I'm just going to do 3 crossings for my first one, which means I need to write that down clearly in my table. Number of crossings is only 3. So let's go for this. 1, 2, 3. Right. 5.43. 5.43. So I need to change my depth now. So I need to get this up to 10 mil. I need to put my glasses on so I can't see the ruler without, and bring this up to 10 mil. So there's my I think that's probably still only 8 mil. Push it up a bit further. And that's probably 10 mil now. Okay, so hopefully I can get 5 crossings at 10 mil. Let's have a look. 1, 2, 3, 4, 5. So 5 crossings at 10 mil gives me 6.53. 6.53. Okay, 15 mil. Oops. Nope, that's only 13, so I need some more water. At 15, at 14. That's about 15. Okay, 5 crossings at 15. One, 2, 3, 4, 5. 5.15. 5.15. Okay, let's pull it up 20 mil. Not there, not quite. 20 mil. Okay, 5 crossings at 20 mil. 1, 2, 3, 4, 5. So that comes out at 450. Right, more water. Okay, let's take this up 25 mil. All right, different ruler. Give me a bit different reading. Let's try that again. 25 mil I'm looking for. About there. So 5 crossings at 25 mil. Starting to get quite a lot of water now. One, two, three, 4, 5. 402. Okay, 30 mil. 1, 2, 3, 4, 5, 6. 30 mil, that'll be enough. 6 points on a graph is enough. So I would prefer 7 points on a graph, but 6 is enough. So let's take this up to 30 mil. Not quite. There you go, 30 mil. If I go much deeper than 30 mil, trouble is it's going to splash all over the place, so we'll probably stop at 30 and do the repeats. Hopefully you can see how much faster it's got. Okay. 1, 2, 3, 4, 5. 391. Makes me wonder about that 402 for 25. And maybe when I do my repeats, it'll come out different, and I might have to amend that first one. Maybe I only recorded 4 crossings and not 5. You guys watching the video will perhaps know that I've made a mistake there, because it looks like that one doesn't quite fit the pattern of the rest. Right then, so what we've got to do now is we've got to do our repeats. Now this is a pain in the bum to have to go through this process all over again, especially as I've just thrown water all over the desk. But it's important, because what we're testing here is not only have I got an ability to reproduce my timings, it's also have I got the ability to get it back to the same depths that it was before. Okay, so there it is with a little bit of water in it. I've got to try and get 5 mil of water in it. So mils, about somewhere around there. Might be a little bit deeper than it was before, something like that. Now if you remember last time I couldn't get 5 crossings at 5 mil, I could only get 3, so we'll do 3 again. One, 2, 3. 537. Oh, that's pretty close. Take it up to 10 mil. Not 10 mil? Not quite, I think. That looks like that's 10 mil. Right, 10 mil, and at 10 mil we'll go back up to 5 crossings and not 3. One, 2, 3, 4, 5. 632. Right, more water. Sorry about this. I'll put my glasses on. I should have got a much bigger jug for putting water in, shouldn't I? Save me all this faffing around. $15 ml, not quite. Gone over a fraction there. 15 ml, we'll call that. So 5 crossings at 15 ml. One, 2, 3, 4, 5. 512. Hmm. 20. Right, that last one was 512, 5.12, which is pretty good considering our first time it was 5.15, so the repeats are going pretty well so far. Let's raise it up now to 20 mil. Okay, 20 mil. 5 crossings at 20 mil. One, 2, 3, 4, 5. 4.81. Now, it's the 25 that, if you remember, I thought was maybe an anomaly. So let's push it up to 25 and see what happens. Not there, not quite. Same, one and big full is not quite enough to increase it by 5 mil. Right, 25. Let's let it settle down a bit. One, 2, 3, 4, 5. 450. Oh, that's very different. Very different. Okay. Last one, 30. Now, only just going to fill on that end. It's almost tipping out that end. I don't know if you can see that there. Okay. So 30 mil, 3 centimeters. 1, 2, 3, 4, 5. 396. Oh, that's very close. So the only one there of my results, 396. The only one there of my results that was very different to the one before were the 20 and the 25. They were quite a long way out. The rest of them pretty consistent. Unfortunately, when you've got two sets of results that disagree with each other, that means you've got to do a third. I know we normally do 3 repeats anyway, but I was rather hoping I could stop. But now, unfortunately, it looks like I do need to do 3 repeats to find out which one is the correct value. Oops, I threw that water everywhere. Literally threw that water everywhere. There me just hit pause. Okay, back again. Let's see what depth I've got here. £5 mil. It's pretty close. Anything I've just gone a touch over. Right, and on the 5 mil one, we can only do 3 crossings. 1, 2, 3. 450, yeah, I thought as much. I'm too deep, I've got to pour some of that water out. Right, should we try again? Yeah, that looks more like what I had on the previous ones. Trying to be consistent. So we're going to do that 5 mil one again because I decided that I've got too much water in it. So let's try that once more. 1, 2, 3. 501. Still not quite consistent with the others, but not awful. Okay, let's take it up 10 mil. Mil. Okay, back to 5 crossings at 10 mil. 1, 2, 3, 4, 5. 655. 655. I think it's 5, not 9. It might be 659 actually. But that's pretty consistent with the first one. Okay, what we're going up to? 15. Ooh, just not quite. Okay, 15. 5 crossings at 15. One, 2, 3, 4, 5. 532, a bit longer than previously. Quite a lot of scatter in these results. That's something you'd say in your conclusion. Quite a lot of scatter. My repeats aren't all identical. There's a bit of, you know, one to the next. Not great. Reproducibility, not brilliant. You're not surprised, are you? I hope you can see on the video how hard it is to get the depths right. Right, let's take it up to 20. 20. Okay, 5 crossings at 20. 1, 2, 3, 4, 5. 482. 482. 4.82. More water. What have I got? 225 I need to get to. Okay. So that reading 23, 24, 25. One, 2, 3, 4, 5. 426. Oh, right in the middle. How interesting. Yeah, so it wasn't that that first one was wrong, it was just representative of the scatter that's occurring, which seems to be getting bigger as I go to deeper depths. So that first one perhaps wasn't wrong, just wasn't great. I was hoping that what would happen there is that my repeat would either confirm the 4.50 or the 4.02, but at 426, 4.26, my repeat falls exactly in between the two of them, and therefore my doesn't confirm or deny either one of them. Just tells me there's a lot of scatter in the experiment, that it's not as reproducible as it should be. So I'm setting it up to go. I haven't increased the depth. Right, last one, you'll be relieved. I'm relieved because I've coated my lab in water. I'm doing worse than when the guys do it for real live in the lab. The amount of water I'm getting everywhere, not quite 30. That's 30. It takes a bit more as it gets higher because the sides of my tray lean outwards a little bit. So it needs a bit more volume to make the same depth increase. Okay, last one, 30. One, 2, 3, 4, 5. 383. 3.83. Okay, so there's my full set of results. Now, that's not it for this particular experiment. No, in this experiment you are asked to calculate the speed. And to calculate speed, you need to know distance travelled. So for my first set of measurements, my 5mm measurements, it travelled 3 times across my tray. So the length of my tray is 380 millimetres or 0.38 metres. So that means that my distance travelled for my first reading is 3 times 0.38, and that'll give me a distance in metres. I can then divide by my time in seconds, and that will give me a speed in metres per second. For all my other measurements, it did 5 crossings, so that means that my distance travelled is not 3 times 0.38, it's 5 times 0.38. So I get my distance travelled is 5 times 0.38, and then I divide that by the number of seconds, and that will give me the speed in meters per second. So you can understand if I do 5 times 0.38, I'm going to get something like, I don't know, 1.8 meters, something along those lines. And if I divide 1.8 by 6.5 seconds, then that means it's only going to be going at about 0.3 of a metre per second. So you're expecting values less than 1 for your final answer for the speeds, and not going hugely fast. But I hope you noticed watching the video that they did increase in speed dramatically. So in your conclusion, you can definitely write that as the water gets deeper, the wave speed increases. But what I want is some specifics in that conclusion. How much faster did it get? What's the shape of the curve when you plot the graph? What was the maximum speed? What was the minimum speed? Those kinds of specifics are what need to go into a conclusion from an experiment like this. Okay, thanks very much, and I look forward to reading your write-ups.